Okay, this is Unit 4, Lesson 4, Using Function Notation to Describe Rules, Part 1. So in this first part, this is a notice and wonder. I usually have my students write down at least one thing that they notice and at least one thing that they wonder, and then we discuss it as a whole class. So looking at this, you may say, well, this one is called function f, and this one's called function g, and it looks like this function f is decreasing and then increasing, and then the x values are increasing and then decreasing. So you can look for patterns here. What I like to do is ask, where do you think this 8 came from, and this 7 and the 0, where did these outputs come from? Well, if you take this 1, or the input, and you plug it in right here for that x, it would be 10 minus 2 times 1. Well, we know 2 times 1 is 2, so it would be 10 minus 2, which is 8. So here's my inputs, my x values. I take those and I substitute them in the function, and then it gives me the output. Same thing here. If I have negative 2 for my input, I substitute it in for the x in this function, and I have negative 2 cubed. So it would be negative 2 times negative 2 is positive 4, and then 4 times negative 2 is negative 8. So that works out. And then 0 cubed, of course, is 0, 1 cubed is 1, and 3 cubed is 27. Okay, look at 4.2. Here are descriptions and equations that represent 4 functions. So you're supposed to match these. So you could pause this and match them by yourself, and then unpause it, and then we could talk about it. All right, so looking at A, to get the output, you have to subtract 7 from the input, then divide the result by 3. So we're going to subtract 7 first. And our input here, you can look, our input in every single one of these is x. Because remember, this is our name of our function. What's in parentheses here is the input, and then what it equals is the output. So I have to take x and subtract 7 from it, and then divide by 3. So looking at these, it would have to be k, the last one, because I take x, the input, subtract 7, then divide the whole thing by 3. All right, look at B. To get the output, subtract 7 from the input, then multiply the result by 3. So my input is x, I have to subtract 7 first, then I'm multiplying by 3. Well, this one looks like it's order of operations. We would multiply, then subtract. This one we would divide and then subtract, but look at this one. We have x minus 7 in parentheses, so that means I need to take care of that first. So I'm subtracting 7 from the input, and then I'm multiplying the result by 3. So that would be B. On C, to get the output, multiply the input by 3, then subtract 7 from the result. This one would be F. And then the last one, D, to get the output, divide the input by 3 and then subtract 7. So we're dividing and then subtracting. That would be H. All right, so we matched it. Number 2, for one of the functions, when the input is 6, the output is negative 3. Which is that function? So I've got F, G, H, or K, and this is what they're talking about. F, G, H, and K. These are my functions. So first I'm going to look at F, and we've got to see when the input is 6. So that means when well, that didn't even change anything. When x equals 6, which function gives an output of negative 3? Or you could say which function equals negative 3, because that's what it means by given output. Okay, so let's try f first. So we have f of x, or equals 3x minus 7. Now we're looking for f of 6 equals 3, open parentheses, 6, close it, minus 7. So we're going to multiply first. 3 times 6 is 18. 18 minus 7, f of 6 equals 11. And you could make this a little larger if you want. Okay, so that is one. That gives us 11, so that can't be it. So now we're going to look at the next one. We have g. G says 3 times the difference of x and 7. G of x equals 3 times the difference of x and 7. Okay, we're looking for a g of 6. So everywhere I see x in this function, I am substituting a 6 for that. So 6 minus 7. So g of 6 equals, well, 6 minus 7 is negative 1. So I'll go ahead and show that step, negative 1. And 3 times negative 1 equals negative 3. So this one is our function. So I guess you could draw that around it maybe. And then over here it says explain how you know. When g of x has an input of 6, the output is negative 3. Okay, so number 3, which function value f of x, g of x, or h of x, or k of x is the greatest when the input is 0? And then they say, what about when the input is 10? So first we have to plug them all in for 0 when the input is 0. So same thing. So let's look at the first one. We have 3 times 0 minus 7. Well, 3 times 0 is 0, and then minus 7 is negative 7. Okay, let's look at g of 0 equals 3 times 0 minus 7. G of 0 equals 3 times 0 minus 7 is negative 7. G of 0 equals negative 21. Okay, so then we're going to go to h. H of 0. H of 0 is x over 3 minus 7. Whoops, it should be 0 over 3, sorry. 0 over 3 minus 7. H of 0 equals 0 divided by 3 is 0, minus 7. H of 0 equals negative 7. So we got one more for when we're evaluating when x is 0. So k of 0 equals x minus 7, and then all of that's divided by 3. So we're going to use parentheses. 0 minus 7, divide all of that by 3. So we have 0 minus 7 is negative 7 divided by 3. And this would be, I think it's negative 2.3 repeating. Yes, so this would be negative 2.333, and so on. All right, so when they're negative, you're looking for the value that's closest to 0. That's going to be your greatest value. So out of all of these, it would be k of 0. That's going to give you the largest because it's closer to 0. Okay, so now we've got to do this again, but this time when the output or the input is 10. So, whoops. So f of 10 equals 3 times 10 minus 7. F of 10 equals, this would be 30 minus 7. F of 10 equals 23. Okay, let's do G of 10. This was 3 times 10 minus 7 equals 3 times 10 minus 7 is 3. So G of 10 equals 9. H of 10 would be 10 divided by 3 minus 7. H of 10 equals 10 divided by 3 is 3.3 repeating, and then subtract 7 from that, you get negative 3.6 repeating, or you could put 6, 7. Okay, then K. K of 10 equals 10 minus 7, and then all of that is divided by 3. Well, 10 minus 7 is 3 divided by 3 equals 1. So looking at all of these, all 4 of these, the largest one would be F. So when the input is 10, the largest function is going to be F with an output of 23. Okay, so look at 4.3. We have rules for area and perimeter. A square that has a side length of 9 centimeters has an area of 81 centimeters squared, or square centimeters. So if I were to draw a square here, and I said this is 9, this is 9. Remember, this area is base times height, length times width, or in this case, side times side, because all the sides are equal. So this would be 9 times 9, which is 81. All right, so the relationship between the side length and area of a square is a function. So complete the table with the given each given side length. Complete the table with the area for each given side length. So when this side length is 1, the area 1 times 1 is 1. When the side length is 2, we have 2 times 2, so the side length is 4. The area is 4. When we have a side length of 4, the area is 4 times 4. Make sure you don't do plus 4 here. Times 4. And we have area is 16. And then when the side length is 6, we would do 6 times 6, and we would get 36. Now, when the side length is S, so this is different, and some students get confused, like, why in the world are we calling it S? Well, if we have this, then it doesn't matter what we plug in for S. We can use the rule and easily figure it out. My square is not very good, but it will work. So if I say my side length this time is S, that kind of looks like a 5, but I'm trying to make it an S. So then we have S. Let me do an equation so it'll look better. Oops. S times S equals, well, S times S is S squared, not 2S. S plus S is 2S, but S times S is S squared. So S squared. And let's see, I think I can enlarge that. There we go, make it a little bit larger anyway. Okay, so S times S is S squared. So right here we would have, I do want to use it. I want to use the equation thing again because it will actually make that look like a squared. It'll actually raise that up, the exponent, so it looks a little bit better. Okay, so now we have our table. The next thing it wanted us to do was write a rule for a function A that gives the area of the square centimeters when the side length is S centimeters, and they want you to use function notation. Function notation, remember, is just the name of the function, the input in parentheses, and then it equals the rule or the output or whichever. Okay, so we're going to have A of S because our side length is S. If we don't know the side length, we're putting S there. So A of S equals then our rule. So we would just simply do, you know what, let me do equation again because I have to square it. So A of S equals S squared. And then I can again enlarge that. So this would be in function notation. Okay, now B says, what does A of 2 represent in this situation? Well, we know A is the name of our function. Oops. A is the name of our function. 2, what's in parentheses, is the input, which in this case our input is side length. So A of 2 represents, let's go back to text box. A of 2 represents the area of a square with a side length of, which is our input, it would be 2 centimeters. So that's what it represents. If we were to say this equals this, whatever we say it equals would actually be the area of that square with a side length of 2. And then it says, what is its value? Well, A of 2 equals 2 times 2, which is 4. And that's it. That's all you have to do for that one. Again, if I'm going too fast for you, you can always pause this, rewind, whatever you need to do to catch back up and understand what's going on. If you have questions, you can put some comments under the video and I will try to answer those. Okay, on C, on the coordinate plane, sketch a graph of this function. So we're going to plot points on this. I may actually make this a little bit thicker so it's easier to see. So when the area is 1, when the side length is 1, the area is, it would be 1, so it would be very, very low. When the side length is 2, the area is 4. So let's see if I can zoom in. When the side length is 2, the area is 4. So right below the halfway mark. When the side length is 3, 3 times 3 is 9. When the side length is 4, 4 times 4 is 16. So that's about halfway, a little bit above halfway. When the area is 5, 5 times 5 is 25. When the area is 6, 6 times 6 is 36. When the area is 7, 7 times 7 is 49. I'm sorry, when the side length is 7, not area. And then it goes to 8. Well, 8 times 8 would actually be 64, so we cannot do that. So you could draw your line here to connect these. It's a little bit difficult to do this on here. I can try to. And it would just continue to curve on up. As the side lengths increase, the areas are going to increase by that much more, or more than that, because this is called an exponential function, and it starts out very small and then grows rapidly. All right, so number 2, a roll of paper that is 3 feet wide can be cut to any length. What is if we cut a length of 2.5 feet, what is the perimeter of the paper? So if we were to draw this, which they have this drawn right here, so we could actually just do 2.5 would be the length, and then 2.5 would be the length here, and then here would be 3. So perimeter is when you add up all the sides. So we would say 3 plus 3 plus 2.5 plus 2.5. Well, 3 plus 3 is 6, plus 2.5 plus 2.5 is 5, so this would equal 11. And this is feet. So the perimeter would be 11 feet. You just add up all the sides for a perimeter. B sets complete the table with the perimeter for each given side length. So then write a rule for a function P that gives the perimeter of the paper in feet when the side length in feet is L. Use function notation. So when the side length is 1, we still have that width of 3. That's not what I needed. Drawing tool. So we're going to just draw this right here. Okay, so when our this is the width of the paper, it stays at 3, and then this time we have a side length of 1. So we would do 1, or let's do 3 plus 3 plus 1 plus 1. So this would be 3 plus 3 is 6 plus 2 equals 8. So with a side length of 1, our perimeter is 8. So you would go through and fill in the rest of these. If our side length was 2, so we have 3 plus 3 is 6, plus 2 is 8, and then plus 2 more for our other side is 10. Okay. If we have 6.3 as our side length, we still have our 3 plus 3 is 6. Then we would have to add 6.3 plus 6.3. Well, 6.3, I'll just type this one since it's a little more complicated. 3 plus 3 plus 6.3 plus 6.3. This would be 6 plus 6 is 12. 3 plus 3 is 6, so it would be 12.6. Well, this would equal 18.6. Whoops, not a comma. 18.6. All right, and then if our side length was 11, so we have 3 plus 3 is 6, and then 11 plus 11. 11 plus 11 is 22, so 22 plus 6, this is going to give us 28. Okay, well, what about when our side length is L? So I'm going to draw this, and you could draw these actually for every single one of those. If it helps you to draw that, go for it. I don't mind at all if my students draw, and if they have to visualize it, I think it's actually really cool that they can draw a picture out and actually visualize what's going on. Some can do it without drawing a picture. I'm not a very visual person, or maybe I am a visual person, but sometimes I have to draw a picture to help me. All right, so we have our width of 3, and then our side length of L. Oh, that was a terrible L. Let's try that again. Okay, so we have 3 plus 3 plus L plus L. I'm actually going to make that, well, I'm going to make that a cap. No, we'll just do L plus L. Okay, so when we do this, this will be, if we wanted to simplify this down, this would be 6 plus, and L plus L is the same thing as saying 2L. Not L squared, that's L times L. But L plus L is the same thing as saying 2L. So our rule here is 6 plus 2L. Now, I want you to realize that if I had said 2L plus 6, it's still correct, because remember, commutative property of addition, we can move those terms around and it does not change the answer. So our 2L could have came in front, or it could have been like this first one that I did. So those are both the same. All right, so what is, oh wait, we got to write it in function notation. So our function they told us was P, so P of L equals, because our input is our side length, which is L. And then we use our rule to finish this out. So it'd be 6 plus 2L, or you could say 2L plus 6. That is our function notation. Okay, what does P of 11 represent in this situation? So I'm looking here. Okay, P of 11, it says, you know, a side length of 11. It gives us the perimeter because we've already calculated that. But what does P of 11 represent? P of 11 represents our perimeter, because that's what the P is telling us, perimeter, when we have with a side length of 11. Or you could say represents the perimeter of the paper with a side length of 11. This would be feet. Okay, then it says, what is its value? Well, P of 11, the output there would equal 28. So P of 11 equals 28. Then we're going to graph it. So when the side length is 1, then our perimeter we saw was 8. So we need to go here and put an 8. So right there, somewhere close to that. Probably wasn't exactly spot on. When our perimeter was 2, our side length is 10. When our perimeter is 3, it doesn't show us that in the table anymore. But look at the pattern. It started at 8, goes up to 10. Then this would be 12. Then when our side length is 4, this would be 14. When our side length is 5, this would be 16. When our side length is 6, this would be 18. And you could check these if you're not quite sure. You could draw a rectangle, calculate it if you need to, add them all up. 7 would be 20. And 8 would be 22. So this should be a straight line. Mine's not exactly as straight as it needs to be, but it is a straight line. So let me see if I can try to insert this line here. Well, maybe you can. So this does make it a little bit better. Okay, so I just clicked and dragged that and kind of made that line, and you can see that my points are not exactly straight. Okay, so this is actually a linear function. It's a straight line, and it was increasing by 2 every time. All right, that is all for this lesson. I know I went kind of fast, just trying to get through it all, and you can pause again as you need to catch up or type whatever you need to type or write down whatever. The lesson summaries are very good. They usually give some kind of example that was maybe from the lesson and just kind of help to reinforce what the lesson was about. Again, if you're not one of my students and you're watching this video, you can always comment if you have questions about anything. And of course, if you are my student, you know how to email me and get in touch with me to ask questions or ask me in class. So that is all.